Hello. So yeah, I'm Josh Piori. I'm a security researcher with OpenDNS, also Cisco, I guess now, because we've been bought by them. Previously, I've worked as a threat analyst at NASA, and I helped build their security operations center for all the agencies. And then I did some work at Mandiant for a little while, and I've been in some other companies, but I've been doing this for a long time, just security stuff, and started the usual path where I started as a system administrator and then worked my way in. I have a podcast, if you guys like podcasts. It's called Root Access. It's we tell like a story with people. We talk to people and we tell like a narrative story with music and everything like that about different security issues. I'm about to finish the 6th episode. I just have to finish editing it. So I'm going to be talking about my work on trying to do behavioral analysis, and it's not perfect, but I'm just going to talk through it, and I'll show you some stuff that I'm doing, and all my stuff that I've written, I've released already on GitHub, so I'll show you how to get access to that so you can play around with it too. But we're going to be using network traffic, DNS, and log data. So when you think about behavioral analysis, it's something like this, where you're watching where users might click on a website so you can better design your website or better design whatever you're designing. You might also be looking for anomalies, like in this case, actual behavioral analysis, people walking and you see some weird stuff. I found this video on YouTube, but it's pretty appropriate. It was exactly what the people were looking for. But we're working with data, with lots of text files or maybe binary data, network traffic data. So I'm going to just briefly go over some most popular current detection methods. IDS uses signatures. So a signature might look like this. You've probably all seen this. I'll just go over it real quick. It's a TCP connection from your external network, which you defined in your config file, to any of your internal HTTP servers or ports. It's got a message which you would see in your event console. You've got your flow established, like a connection is happening. It's looking for a certain kind of content, in this case .php, and also some regular expression content, so we can be a little bit dynamic. It's looking for patterns of behavior, and it's got a reference and ends with a wink at the end. But it's not very adaptable. It requires human intervention to change with changing environments. It catches known threats, some unknown, depending on your regex, if you've done it right. You've got antivirus, which is host-based, as we all know, and it's based on signatures of known threats, and I'd say it's not the best. You're not going to catch everything because you have to see it first. So what we're going to be working with is things like CSV files, where you have someone gives you a CSV file. You have to figure out how to find the stuff that is bad in that file. It's hard when you talk about this kind of stuff. You want as much data as you can get, and sometimes you don't have a lot. We're also going to be looking at pcaps. This is just a screenshot from Wireshark, and I'll give a demonstration of this later on. Some stuff I'm working on. Active Directory logs, so we can kind of get a picture of what's happening on a network, and proxy logs, DNS logs. So looking at this, here's a CSV. This is one thing you could do. It doesn't really matter what you use, but I'm using Excel just to show that you can get some kind of information if you're just working with a CSV file. This isn't always effective because it could be huge and it won't really work. But you can sort your items, looking for the most connections to things, to domains or IP addresses. And then you can make a graph out of it to get a visual image of what it looks like. So you can see where maybe you want to focus. It's really loose and kind of messy, and also you can tell, text is very small, but the CSV is all the domains plus subdomains. So I don't know, it's not the best, but we want to find normal. That's what we're looking for. So what is normal? Normal is, it depends really, but it's what the average behavior of your network or your environment. How do you find it? Hoping to figure that out during this talk or explain it. looking at this, you can see these are a bunch of domains. And they look really suspicious. This might be normal if this is all you see on your network. They were actually found, I work at OpenDNS, so I have access to a lot of data, which is great. These were found by something we use to find DNS tunneling domains. So they follow a certain pattern. They aren't all DNS tunneling, but they're all weird. But how do you find it in something like this, where you have a list of domains that are just scrolling by in slow motion? A lot of these are normal, but then you have this weird thing, and like, what is it? Why is it there? How is it something compared to the rest of the domains? And how do you find it in this? If you're even watching the network stream in such a manner, I wouldn't imagine you would be TCP dumping and watching it with your eyes, because you're getting nothing out of this except a cool show. So. Well, how do you find it in this CSV file? This is a different CSV file than what I just showed you. So looking at this, I'm going to just take the largest amount of visits to various domains, and I can see, I don't know what's going to happen here. I can see a bunch of Facebook, so let's just pick the Facebook domains. We grab those, and we can see there's a bunch of visits. These are still Facebook plus subdomains. Looking at that, you can kind of graph it. You can get an idea of what that looks like if it helps you. Then you can take away the subdomains to get a more even picture of how things look. You can see the Google visits to Google and subdomains of Google are the most in this specific CSV file. And so on, Facebook is actually fourth, and you can go down the list. So you're kind of working to look for what might be normal. It doesn't mean that it's good. There might be something that is visited a lot. Also, things that are visited a very minimal amount doesn't mean it's bad, but I'll get to that. So we're going to remove normal from this file. When we do that, we see that we've got, I just selected all the ones that have one hit, one visit, and like I said, that doesn't mean it's bad, but it gives me, I don't have to go filtering through all that other stuff. Now, taking from that CSV file just a random chunk of stuff, I'm doing this really to show the process, the manual process. Take a random chunk of stuff, and I look at this and I can see, oh, well, and these were all visited one time from that CSV. And I can see that there's a bunch of stuff just based on my know-how or whatever, that these are legitimate. So I'm just going to remove those from my thing. I'm going to look at these ones. These ones I think are fine too. There's like a CDN in there. I mean, maybe they aren't, but I'm just going with intuition here. I can look up the specific domains that kind of are interesting to me. So I can see this one, oh, it's a medical or Medicare supplement. It's some kind of medical site. So I'm going to cross that off. I have this one, ministerial5.com. It's kind of weird, but it's got an Apache default page. So I'm going to come back to that one. I've got mom.me. It's like a parenting blog. It was visited once. It's probably, ideally you would be doing some other analysis. So if maybe, blogs are commonly compromised, but maybe you would be seeing what else that machine contacted right away after that, but probably not a big deal. So I crossed that one off. I had this one, unable to connect, so there's no content. So we'll come back to it. Come back to this one too. That's pretty interesting. We'll just come back to that. And this has no content, so we'll check on that. So let's look up all of these. This is still this manual process. This domain, it's not really giving me much. It's apparently used by an advertising company, so I'm going to cross that out. What's this? This is used for Windows machines for verifying network connectivity, so I'm going to cross that one out. This one, I don't really care. Doesn't seem like anything special, so I'm going to cross it out. And then I've got this domain. There's some information there. Threat crowd, open source threat intelligence, so maybe there's something, but I'm not getting any hits with AV. Doesn't mean it's not bad, but I'm just going to move on. Then I have this last domain here. I look it up and I get some cool stuff, like someone's uploaded a sample to malware.com, and that sample calls out to this domain, does like a GET request, And then you can see that there's some other things like hybrid analysis, a great site. There's a zip file. Inside that zip file is something that calls out to this domain, probably the same file. Looking at another source of intelligence, I can see it's been identified by at least one antivirus company, performs some requests, steals information, does stuff, and installs itself to auto-run at Windows startup. So then looking at virus total, I can see there's a bunch of URLs that are interesting. And then looking at data from OpenDNS, I can see that there's a spike in traffic. OpenDNS only gets 3% of the internet's DNS requests. So you see that there's only about 30 requests at the height, but I mean, this is a small portion of the internet. But it's good enough to see that there's nothing happening, and all of a sudden there's a spike, and that's kind of suspicious. And based on all the other stuff, you know that it's probably bad. So as you observed, the process is pretty tedious. So it's mostly manual. You can automate that, but for the moment, it's manual. It's based on searching and personal expertise. So you require analysts, people to do this. So we want to automate that process. So we would auto-process logs, streams, make it so you can upload a file, or it's automatically just taking stuff in. And as we go on, I'll show you how I'll actually show you that happening. We want to save that data so that it's workable. So getting this data, it's kind of redundant here, but we'll be getting DNS, AD, system, web stuff. You can get that stuff from syslog or from Logstash. You could send it into Elasticsearch, which is a really efficient database system, or no database system. For my examples later on, I'm using MongoDB. I'm also using examples of just static flat files. You can do network capture, so if you have monitor port or span port, you can pipe all your traffic through, and that's what I did in one of my examples here. You also have to write parsers for this data. So the stuff I've released that I'll show you at the end on GitHub, I have my own parsers for my own data. Some of it might work for you, but you would, you're gonna have to adjust it to fit your data if you want to play with it. But ideally, you take that your data and then it goes into a database, or it goes into the next level of scripts, and those scripts, you kind of normalize the data so that you can work with it much faster, and you don't have to mess with it later on down the pipe. So you want to use whatever's easiest for you, Python, Excel, R. I use Python for all my examples because I've been doing it for a couple of years with Python, so I'm still new, but it's comfortable for me. It's unfortunately slow when you're dealing with large files like I've dealt with, over a terabyte of files, and it's just, you can do multi-threading, but it's just slow. Excel I don't recommend, but if you have to do it. And R, I would recommend R. I didn't have enough time to really become proficient in R, but it's much faster than Python and great for data analysis. So creating a baseline, we're going to count the total number of domains as an example. We're going to get scores, kind of like we're going to see, well, I don't know if I can describe that. Let's see. We're going to score the domains based on various attributes like ASN that it lives in, bad stuff that we see on it. We're going to categorize the domains, so if it's something like shopping or whatever, just to get an idea of what kind of stuff you're seeing on your network. So I do a few case studies. I'm going to start with data from OpenDNS, and this is you'll see. So we get over 1 billion queries per day, approximately 3%. How do you baseline that? Is it possible to baseline that? I don't, you need a lot of data if you're going to baseline random data from people. Can you baseline it? I don't know. So looking at this is, I'm just looking at one log file from one of the resolvers. There's resolvers all over the world, so it's a lot of data, and this is what it looks like. So I wrote a parser that will grab the stuff I need out of here. Let's try it, see what happens. So we're going to count how many times the domain's seen. Over 10 times, we're going to write to a file called normal traffic.txt. Under 3 times, write to suspicious traffic.txt. This file right here is 9 minutes long, starting with that one to there. So it's not really a lot, but then you look at the line count, it's 664, almost 670,000 requests. Some of them are duplicates, so it's not all unique. You can see the file size is 61 megabytes for that thing. I've got my Python script just below it, and then I've got the two files I talked about. The normal traffic is 247 kilobytes, so it's not that big compared to the suspicious traffic, which I was hoping to narrow down a little bit, 6.4 megabytes, the text file. And when I cleaned it, I took out all the extra stuff I didn't need. So it's timestamp and domain, basically. So that's a huge file. Just to show you, just because it's easier, I'm looking at this in a CSV format, like in Excel. Like I said, don't use Excel. But, you can see this is normal stuff that's visited normally, and it's all pretty normal. I mean, Google. I guess I draw little boxes around here. Gotta wait for it. Okay. So suspicious traffic. I've got things I chose that were visited three times. I've got this one domain which is suspicious to me. I live in America, and when we see on an American network a visit to a .ru, a Russian domain, we usually we look at it just to see what's going on. So that looks suspicious, so I look at it using just some OpenDNS stuff, and I can see there's what looks like normal traffic to me. This is what the site looks like. It's probably fine. There's another one, this KZ, that looks kind of weird. It was visited once. Go look at it, and you can see down at the bottom here, it's actually blocked by my company as malware, as a dropper for Locky. So I sort of eyeballed that after doing a little bit of analysis, and I still want to automate it further. Looking at that domain, by the way, this is like, I believe it means that it's been taken down. But it's, so categorization. You can categorize this stuff if you have a source for categorization. Again, I work at OpenDNS, so I have categorization, but there are open source versions, and I plan on, in my code, I've written a lot of stuff involving OpenDNS, but I plan on adjusting that so that you can apply this to your own data and get categorization from free sources, because I believe that we should all be able to do this, whether you pay or not. But looking at this, you can see there's a lot of dynamic DNS. I mean, the kind of vague categories, malware botnet. And then you've got a whole big, huge section of blank. So those aren't even categorized. So it doesn't really help a whole lot. So you can look at the bandwidth of the thing. You can see there's this 9-minute stretch of data, and you've got a decrease, an increase, but it really doesn't mean much because it's random data from unrelated sources. So we have to narrow this focus a little bit. I thought that'd be a cool experiment. It's kind of hard to do a baselining of the internet. So we're going to look at DNS for one organization. So this is a file from one organization that I've worked with at one point. I don't remember where I got this, but it's a lot of lines of requests. And it's going from May 19th, 17 hours approximately of data. Now looking at it, just seeing what it looks like, you can see based on this, there's a whole bunch of visits to directtv.com for some reason. It's just eyeballing it. And there's other stuff in there too, but I'm not going to be able to find anything bad in this thing with all those pretty much normal things. So I might want to go and remove that. So you can see that I've modified the file so that I've taken out, I didn't show you the original file, I'm sorry, but I modified it so it's just the timestamps and just the domains, so that's down to 875 megabytes. It was originally 2 gigabytes of data. And then this time I'm going to remove everything with the line DirecTV in it, or DirectV. I hate the way that they say that, DirectTV, to a file called Slightly Clean. This is still a manual process. I do a word count of that, and it's much less, 493,000. And then I further processed it to mindomains.txt, so it's 1320. So it's much more workable. I'm sorry about this graph. This is when I was first starting this project, so But you can see there's some connections at various times. Maybe that gives you an idea, but that doesn't really help me. But this is a better graph showing what I'm seeing. I took a picture of this because of the 666. It's pretty cool. Anyways, you can see there's a lot of Yahoo, and there's a bunch of other stuff. You see, you could go through. There's some mistakes here in my initial stuff, like com and dot. I didn't sanitize my data properly. Also, it took forever. It's just doing this one little part. I was initially doing this in IPython notebook before I switched out of it and to do stuff on server-based. But you can see it's using up my processor, and my fan was loud, and the computer was hot. I couldn't use it for anything. So another idea is to if you have DNS data, which is streaming, I mean, you do have streaming DNS data, you can look at it on the wire dynamically as it's going. You process it with various tools like Python and pandas, and it's going into a database. This case, here's what I did at home. I wanted to watch my network traffic for about a month, maybe 3 weeks. So I ran TCP dump on ETH1. ETH1 is attached to a little one of those Hack5 throwing star LAN taps, and so I'm watching my network between. I don't think it's actually between the internet port and the cable modem. It's actually a little bit closer in because I wouldn't get the DNS requests the way I wanted them. So anyway, I'm writing it all to this file called tcpdump.log. It looks like this. It's sloppy and kind of messy, but it's not a proper DNS log file, but it doesn't matter. You can do this with any kind of file. You can see there's domains in there and there's timestamps, which is what I'm interested in. And looking at it just for convenience in this CSV format, you can see these are the ones that are visited once. And then looking at that in a kind of plotted, you can kind of see this sort of gives you a picture of what's going on. I didn't do this version on a time series. Time series would be useful to see where I am, but I'll show that in a few moments too. You can see I've got this one spike, which is unusual. Not unusual to me, but unusual. It's to privateinternetaccess.com, which is a VPN service I use to encrypt my traffic. So that's suspicious if you're not expecting it. That's me when I don't want to be monitored by you guys. So, but that's like, yeah. But it's definitely something that stands out. So let's see. So we're going to compare some traffic. This is kind of a timeline of that month. I cut out kind of the end. There's a lot of stuff that isn't pertinent in here. And you can, the domains over there, the way I did this plot, I'm still learning with the plotting. It's not great. So you could more focus on the timeline and to get a picture of what's happening. So you can see, so September 22nd, this is, I didn't mark what day this was. Let's go to the next one. Well, it's going to be going from 0 hour to 24 hour. You can see at this time, I was at a concert. Someone was home doing other stuff. This is me actually getting home, so I'm doing stuff. I don't know, probably awake. You see I'm at work during this time, so it's less traffic, just mainly machines talking to machines. And then I'm home and there's more traffic, and unfortunately this isn't as accurate because it tries to fit, it just fits whatever it wants on that side. I haven't figured that part out yet. But there's Netflix, I'm probably watching something. On a Saturday, it's kind of quiet. I don't know what happened over here. Maybe I went to dinner, went out, maybe I just stopped looking at the internet for a little while. You can just keep on going through and finding these patterns. Sunday, I was I do stuff in the morning, I don't know. But eventually after you watch this for a while, you can kind of get an idea of when I'm home, what I'm doing, what I'm into, basically. Wednesday, that one's weird, I don't know. I'm sorry, the color changed for some reason. I switched to a different server to make my plots because it was using all my processing power. So, let's see. It's pretty slow traffic right here. So looking at this in context with the other stuff, you can think something's up. Maybe I'm just not online, but actually I went out of town. And then Sunday, you can see, I came back into town around, I was back home around 7. And I still, a lot of these domains, I mean, I didn't go to these domains, so it's interesting. But I probably went to Dropbox and Imager and Google. But so there I'm home. There's a little bit of redundancy here, I think. So here I'm at work. This graph looks crazy, I don't know why. I'm at a Peaches concert right there. And then I'm home watching Netflix a little bit later because I'm wide awake from the concert. I'm going to skip these ones. Just the same kind of pattern. So anyway, I'm going to get to stuff I've created to make this a little easier to work with on streaming data. So if you're creating a dashboard, I've got scripts to auto-push streaming data into a database. I'm using MongoDB just because it's easy, and I really like Elasticsearch, but I just chose MongoDB because I did. So I have other scripts that auto-process that data from MongoDB. And for the purpose of this demonstration, I'm doing it all on my laptop here, but I have a server out there that I can send data to securely and have it do stuff. But you never know if you have internet connectivity, places like this. I use Flask to serve graphs and statistics that might be useful to me as I build this. Actually, I'm going to show you that. So let's see. I made this, let's see. Well, so I started the MongoDB server on my thing. If I look at the DBs, you can see I've got a couple of databases. I got pcap and tcpdump DNS. So this has, in this case, it actually has that entire month-long log file of my DNS at home. So you can see this is what it looks like, just a bunch of stuff. So I'm going to pull it out using Flask. I'm going to exit that. And then so I've got this, for the Flask app, I'll just actually just start this because it'll just pull the data. So I run that, and then I go to a browser, and so it processes that data and gives me some statistics so I can get some stuff, unique domains, total IP addresses seen. I haven't done a lot of exploring of IP addresses just because I'm focused on domains, but this is all in progress. It's certainly not done. I mean, I really only got this part working last Sunday. But I've got kind of like I'm sorry, it's the attachment to this thing. It makes it so that it's really blown up. But you can see sort of the stuff that I look at based on the categorization. I'm pulling this from OpenDNS, but like I said, I'll be pulling it from open source public sources so that anyone can use this kind of thing. But you can see I have one phishing domain in there, and I haven't yet added it, so I can click on this and see what that domain is. But you scroll down. This time series doesn't make sense. But this one, you can kind of see an image of all the traffic and all the domains. And I didn't format it quite right, but I'm getting there. But you can see there's that spike in traffic right here if we zoom in. But that's just Google user content. I've got one domain that's kind of blacklisted. It's voteonline.com. It was actually like a kind of a fake voter site. I went to it so I could have it in here. Got non-categorized traffic, traffic that doesn't have a category, like a security category, like it's not malware, it's not something. And I have suspicious traffic, and unfortunately, I didn't get that one perfectly right. But if I go, let's see, this is the actual HTML file I wrote to. But I mean, it's kind of a mess to work with, and I'm still working on that. And whitelisted traffic. This is traffic that has been whitelisted because it's safe, deemed safe, like eBay.com, things like that. So that's sort of some basic statistics on that stuff. And then if I go to pcap, just looking at pcap data, just exploring this one too. So we're using DPKT Python packet library to take apart the packets and get the information I want. I'm grabbing all the HTTP requests, and I'll just show you what that looks like. I'm actually going to run this one. So if I go into, so this folder I'm showing you, this is all, with the exception of a couple folders, on my GitHub. So you can download it and play with it if you'd like to. So the pcap, I've got a few pcaps we're going to look at, like this one we're going to look at first, this HTTP traffic and post to phishing. I captured a phishing, a login to a phishing page. So I'm going to see what that looks like. I mean, you open it with Wireshark, it looks like this. Well, it looks like that. Well, I'll just leave that going while I'm going to run my script, which is this one, which it's kind of long. I write lengthy Python scripts because maybe I'm still too new. But so if I run, so I'm running a special script I have with NoDB. It takes a flat file and creates, it's going to create some files in here. I've got this, just these two files which are there for now, so I'll leave those there. And I give it the name of the pcap, and it takes a second. And we'll see. Oh, there's that thing. That just opened up just for some reason right now. Whatever. Is this one of those demo things? Where it works every time except for now? Let me quit Wireshark. Look at that. All right, well, there's my stuff. So it finished. It's kind of the same format. I can see there's 255 GET requests seen, 2 posts seen, 3 source IPs, destination. I've got a little graph if you want it. But I've got these GET requests and some general information. You go all the way down the bottom, I can see, a little bit messy there. I can see these posts with the email and the password that were submitted. I can see the times that it happened. I've got a little map of where all these connections were made. So this is the GET requests. The posts, it didn't show up on the map because I think that it wasn't associated with anything. It wasn't able to find it. All this stuff is local though. If you want, you can run this offline if you have this code. I included the database for the geolocation stuff. So this is just a beginning of me trying to figure out like that kind of thing with pcap data. I mean, we could look at another one, which is like the Citadel pcap. So I'll just run it real quick. Citadel is a banking Trojan. And it's just going to replace all those files in this area. So it's a little bit of a bigger pcap, so hopefully it just goes. But I just downloaded this morning from somewhere. Okay. You can see it just updated at 2:38 p.m. So we've got 108 posts to one from one source IP, one destination IP. Looking at these posts, you can see that there's, those ones aren't giving me anything, but you can see there's some interesting data. And you can further process on that data to get something more interesting. So that's kind of the next steps is to watching live network traffic and finding these kind of weird, like this is not a normal post. Posting to one place, that time series doesn't really work. There's no GET request, so there's nothing there, but there's this one post, this one location right here. And I mean, it's on a map, it's an SVG file, but you can grab those coordinates. You can decide that certain coordinates are bad for your environment, they aren't normal, and you can say that when you see visits to that, flag it as something unnormal. So that's also in the works. Going back to, I think I just Let's see what this is. Oh yeah, so if you're doing continuous, that's really what I just said. So I'll just show you one more thing, one more little demo, just playing, or maybe I have two more. Playing with Active Directory logs. I won't actually run the script, I'll just open up the file. So, and I'll show you what it looks like too. So this is exported from 80 logs of an environment. It's kind of a mess. So if I look at just the stuff I want, the account was logged off, logged on, basically log on, log off, attempted log on events like that. So I want to find some unusual behavior. Just looking at that, let's see. Got this weird one right here. Well, that might be a mistake. But you can see it looks pretty consistent. It's not a very large file, so you aren't getting a lot of great use out of this. It's in the morning. It's pretty consistent. I'm not seeing anything really crazy. Ideally, you would layer these next things on top of each other. So you have these logon attempts. These are attempts that were unsuccessful, I believe, or maybe I may have programmed it wrong. I just finished this program last night, so and we all know what happens at night, drinking. These are failed login attempts, so ideally this would be right on top of the successful logins. So I'm working on that part too. But you can investigate these and see if they're suspicious or if and what user count is doing that login, what user count they're trying to log in as. Right on top of the successful logins and see if there's a successful one just immediately afterwards. And if there isn't, then you alert on that kind of thing. And actually, I think that is the last one because I was working on some off-log events using SSH logins from a honeypot that I have, but I was programming that and then lunch happened. So, but and that's actually all I have to talk about for now. I'm actively developing it. I finally just got somewhere within the last week and a half. So it's going to accelerate quickly. The next steps are, I work with a lot of great people who do really cool stuff in machine learning. So the next steps are to involve some things to do automatic analysis. So if you want to download it, it's that one on the bottom right. I've got some other stuff too, but and then I've got my contact information, Twitter, and yeah, if you want, try it out and play with it. I'll keep on uploading to it, and feel free to add to it if you want to. So, anyone have any questions?
Did you have a chance to test it against, for example, Mirai botnet credentials, Mirai botnet command and control DNS queries? I can give you pickups for that, and we can have such pickup in less than a minute after I connect this camera to the internet.
Oh yeah,
I have with me.
Oh yeah, that'd be awesome.
Because Mirai spreads, Mirai controls command and control starts with DNS query to a suspicious domain, and he gets IP of CNC by DNS query.
Yeah, at least we hope so. Some cases it's usually right to the IP, or in server ransomware, it's just everything's downloaded at once. And that would be cool. Let's talk.
Hello, thanks for the talk. One thing, or I might have a few questions maybe. One thing, I noticed you mentioned something about the geo IPs and coordinates being trusted or not trusted. How reliable do you think it is? Because we are monitoring some moderate-sized companies for Austrian standards, I guess, or smallish for other standards probably. But and we see stuff like Chinese employees and Russian employees and such things. Mm-hmm. So I have come to mistrust GeoIPs, but wanted to ask your opinion. What do you think of that? So are they trustworthy? Like
what I think of when you've got employees that are legitimately going to their sites. Yeah. I feel like just like security solutions, it's not like you don't choose one, you choose multiple options. So you watch the geolocation, you also watch their machine behavior, everyone's machine behavior, everyone's network traffic behavior, what follows their traffic to those sites, what precedes the traffic to those sites. So there's a lot more work to be done in this specific thing and in this field. And obviously, I'm doing this by myself. There's companies that do this really well. But yeah, it's all about more than one thing and having context, general context.
Makes sense.
Yeah.
Thanks. And another question, if I may ask, are there any reliable, decent sources of categorization, that are freely available, or can you recommend some?
I started to explore one with Google, but I think I ran into some trouble. I plan. This is like it's bugging me. I need to. There are.
Okay.
But I have a feeling in most cases it's going to involve doing some scraping of sources, not like sources that don't have API calls available. This is frustrating. Google does. They have like security categories that you can get, but then you have to pay for that. Yeah, it's a struggle though. Yeah.